particular factor. Now, that means that if we've got 20 and 20, we've got somewhere between 20 and 400 individual histogram data points. So we're going to decide based on when it runs the stats. Now, what kind of stats are you going to run? Well, I've got a lot of customers who just say, update statistics, name of the table. Anybody know what the flaw with that is? When you do just an update statistics, only update the statistics for the leading column of the index. So if every index just has one column in it, it doesn't matter. But if you have multi-column indexes, compound indexes, what ends up happening is you don't have stats for all the columns, which means that if you have a complex query, how many people here have really easy queries that they're always running? No hands are going up for those of you who can't see it on online. Everybody has complex queries, otherwise you don't have to worry about the tuning. For the more complex queries, you may not get the best optimization plan. So what you need to do is do an update index statistics. The index statistics gets you columnar information to the index columns that you've got taken care of. What does this mean? Well, to start with, if we're going after stats on more columns, we've got a little bit more work that's being performed at update statistics time. Second, if we've got stats that are being performed on these columns, we need to sort the columns. Be careful doing an update index stats on, say, a 300 million row table if you don't have a lot of space in TempDB, because that's where the sorts happen, and you do need to make sure you've got that. Now, one of the things you can do to mitigate that one when you're updating your stats is to use a sampling. Reduced sampling. You do not need to sample 100% of your data. Why not? Well, a friend of mine, Eric Miner, co-authored one of my PMT books with me, used to work at Site-Based Engineering, and he did a lot of the benchmarking internally there. And we're benchmarking the steps. What they found was that if you do a sampling of 10%, you're getting the same query plan that you got if you're sampling at 100%. Now, I'm a little bit paranoid because I'm a DBA. So rather than 10%, I'll start at 25%. Give me a little bit of overkill. I'm still only sampling 25% data instead of 100. The sort's coming dramatically down. I can sort 25% of the data a lot faster than I can sort 100% of the data. We get all of the index stats taken care of. We get the statistics that we need. We can do them more often. We can do it on more data. So, back to histogram steps. What are we doing with the histogram steps? Well, I would start at a bigger number than 20 if you have a significant amount of data in your system and the data is at all volatile or at all growing. Number of steps I tend to pick is about 200. I've seen documentation recommending 500, 1,000. I've seen other documentation saying is more than 100. So, battle of the documentation, what are you going to go with? Go with what works. I have found about 200 histogram steps, particularly in the larger tables, great. I've found that a histogram tuning factor of about 20 seems to work out great. Note that in the very early releases of 15, the defaults were 20 and 1. The later releases, it's 20 and 20. The reason for that, tech support and engineering found that the histogram tuning factor was so important, they want to make sure everybody takes advantage of it. Semantic partitioning. Site's newest toy. With the advent of 15, we've got the capability of determining ourselves how the partitioning goes. Now I've got a separate or so lecture on semantic partitioning, so I'm not going to try to cover all the ground here. But let's talk about some of the stuff that we can do. Your securities industry. You've got, 7 years, 10 years, whatever number of years the regulatory folks have decided this week you have to keep online. So keep that amount of space online, and what happens? Well, you've got 500 million rows of data in a particular database. With that 500 million rows of data, how much of that is current information that you're accessing on a continual basis? Sometimes you can have a day's worth, sometimes 3 months' worth, sometimes a year's worth, probably not the whole 10 years' worth. Now, there are some analysts who are going to say, yes, I want to run some analysis on this 10 years' worth of data for this security, and we'll let them worry about whether that's meaningful information. I'm the database geek, I'm not the data analyst. As we're looking at this, though, we need to make sure that this is efficient for all the stuff that's going on right now. With semantic partitioning, we have the ability to spread the disk stuff out onto different types of drives, whatever our SAN will support. So maybe within our SAN, I've got some cheap RAID 5. I've got some less cheap RAID 10, and I've got some very expensive solid state. I've got the ability to do is say, okay, I've got a partition. My most recent stuff is going on the solid state. I have another partition. Oh, the last 3 months worth of data or so are going on the RAID 10. Oh, gee, anything past that? We almost never look at it, but either the regulators or the analysts or whomever says we have to keep it online. Well, guess what? It goes on the RAID 5. It's not being changed. It's probably accessible as fast as the RAID 10 or almost for all intents and purposes, but we're able to save a lot of cache money as opposed to memory cache by giving ourselves the capability of moving this onto different types of storage. But semantic partitioning does other things as well. Based on these partitions, I can choose to index on a per partition basis. That means if my most recent 5% of information is the most valuable to me, wouldn't it be cool just to create an index on that 5% of information that I'm hitting all the time? Guess what's going to be more easy to use? An index on, a million rows worth of data, or the index on 100 million rows worth of data? Well, we're going to have a lot less index levels, and any scans to the index, any index traversals are going to be much smaller. How much is the data that was 3 years ago changing? Probably very little to never. Well, do we need to run an update statistics on that portion of the table? Do we need to run DBCC's information that's never changing? My answer to that is probably not. So we also get the ability with semantic partitioning to be able to just pay attention to the changing or most recent or most used portion of the information, just run the update stats on that. One of the problems we have with things like updating our statistics is that when we go to update our statistics on, say, 500 million row table, let's change it from millions of rows to gigabytes. A table which is 500 gig in size, how long does it take to scan 500 gig? Well, I can just scan that portion of the table that's volatile. That becomes very interesting from a maintenance standpoint, because now my maintenance window goes from an entire weekend to an hour or two or less. All by itself, the reduction of the maintenance window can pay for the semantic partitioning above and beyond the performance benefits you get. Now, when you implement this, make sure you think through your partitioning approach and test it. This client site that I was at last week, they're in a situation where their user community does not trust their DBAs. Have you ever been in that situation? And it's usually without cause, because generally the problem is with the code. What's the Gartner Group study say? 80% of your problems are in your code. But everybody always blames the DBA. I think because there's fewer of us, and it makes us easier political targets. From a practical standpoint, you need to test this. So we're in the room. I've got the user community asking me questions. Why? Because they don't trust their own DBAs. We're extremely competent. They're very, very sharp folks, been around a long time, but no one believes them. You may have heard this story before, too. It's amazing how many times I've been brought in to tell a group the same thing that the DBAs already knew because they needed an outside consultant to say so. But, hey, if you pay my rates, I'll come walk your dog. I don't care what you want me to do. The semantic partition, they say, well, gee, we had, I was at a user meeting, and and these are all business users asking me this question, and one of the other business users said to me, they went to semantic partitioning, and they said, if you do that, make sure you get your calendar out because it's a lot slower. I said, I've played with semantic partitioning. I've implemented this, and if you're using it right, things can fly. So make sure you're doing the right stuff with the semantic partitioning. There's ways of screwing up anything. I think that should find one. So semantic partitioning, good stuff. Next, sync versus direct I/O. Has anybody played with this yet? With the advent of 15, Sybase created an additional I/O approach, which they call direct I/O. Being a database geek and not a hardware geek, I'm not going to try to explain the differences between the two. Maybe we can get Terry to come up here and talk about the differences and how they actually play into the hardware platforms. Me, I'm a benchmarking guy. I will test them and say, whatever works fastest, that's what I'm going for in my environment. You may have differences in disk architecture. You may have differences in caching architecture. You may have differences in you name it, which makes one or the other approach faster. Now, with 15, Sybase does recommend direct I/O. Here's the catch. Whenever Sybase recommends something, I benchmark it. Is there anybody who doesn't do that? Okay, hands are going up for those of you who are on the video conference. And what I found was that on certain hardware platforms,